this is Ma'am Sheila again. We are still in Module 1 that is about quadratic equations. For today, we are now in competency number 4 that has something to do with the relationship between the coefficients and roots of quadratic equations. For this competency, we have actually two subtopics. The first one is sum and product of roots, and then the second one will be obtaining the quadratic equation. In getting the sum and the product of the roots, we are not going to get the actual roots, the x sub 1 and x sub 2. For us to find the sum and the product of roots, we are just going to use the ratio of the coefficients a, b, and c of the quadratic equation. For us to determine what is that ratio that I am talking about, let us consider the quadratic formula. We all know that in the quadratic formula, if we are going to take the positive root, that will be our x sub 1. Therefore, our x sub 2 will be taking the negative root. So, considering we have x sub 1 and x sub 2, if we are going to add the roots, if you are going to add the roots, you are going to add x sub 1 and x sub 2, what will happen here? You will take note, or you will see here that we have here similar fraction. So in adding similar fraction, you are just going to combine the numerator and you are going to copy the denominator. If we combine the numerator, we have negative b here minus b, that is equal to negative 2b. And what will happen to the other expression? Positive square root of b squared minus 4ac and negative square root of b squared minus 4ac is equal to 0. So we can already cancel this out. And then we are going to copy the denominator. We have here 2a. If we do that, we are going to cancel 2. That is why to get the sum of the roots, we are going to use the ratio negative b over a. Again, to get the sum of the roots, you will be using the ratio of negative b over a. Now, how about the product of the roots? We are going to multiply the two roots here. In multiplication of fraction, we have numerator to numerator and then multiply denominator to denominator. If you multiply the two numerators, you are going to notice here that we have negative b. That is our first term. And then our second term will be the square root of b squared minus 4ac. The difference is that we have plus here and then we have a minus there. It means that this is an example of sum and difference of two binomial. Wherein the rule is you need to square the first term, which is negative b. You are going to square. And then the second term, square root of b squared minus 4ac, you are going to square as well. If we do that, negative b squared, the answer will be b squared. If we square this expression, what will happen is that cancel this one. So what's left is b squared minus 4ac. But take note, the operation here is subtraction. The rule in subtraction is that you need to change the sign of the subtrahend. So if you are going to change the sign of the subtrahend, b squared will become negative and then 4ac will become positive. So in the resulting equation, b squared minus 4ac, b squared minus b squared is equal to 0. So we are going to cancel that out. So what's left will be 4ac all over or over 4a squared. And if we simplify that, we are going to cancel 4a. We will be having a remaining a here. That is why to get the product of the roots, you are going to use the ratio c over a. Again, the only thing that you have to remember is if you get the sum of the roots, the ratio will be negative b over a. And if you are going to get the product of the roots, the ratio will be c and a. Now, let us apply the ratio that we derived. Considering the quadratic equation x squared plus 7x plus 12 equals 0, we are going to get the sum and the product of the roots of this expression. What are you going to do? To get the sum, again, you are going to use the ratio negative b over a. So we have to get the values of a, b, and c, or the coefficients. If we get the coefficients, then a will be equal to 1, b is equal to 7, and c is equal to 12. Using these coefficients, to get the sum, you have negative. the value of B is 7 and the value of A is 1. So if we get the sum, that will be equal to negative 7. As simple as that. And if we get the product of the roots, the ratio that we will be using is C over A. Substituting the values, our C is 12, our A is 1, therefore, the product of the roots is 12. Now, how are we going to know if these values are actually correct? Let us get the actual roots. The expression x squared plus 7x plus 12 equals 0 is factorable. So let us find the roots using factoring. The correct factors are x plus 3 and x plus 4 because 3 times 4 is 12 and then 3 plus 4 is 7. So if we are going to get the roots, the next thing that we are going to do here is to use the zero product property. Then you will be having x plus 3 equals 0 and x plus 4 equals 0. Using addition property of equality, our x sub 1 will be negative 3 and our x sub 2 will become negative 4. To check if these two are correct, we are going to get the sum x sub 1 plus x sub 2. So you have negative 3 plus negative 4 and it is equal to negative 7. Therefore, this one is correct. And if we are going to get the product, x sub 1 times x sub 2, negative 3 times negative 4, it is equal to positive 12. And we have a positive 12 here. Did you get it? Now, let us consider another example. We have 2x squared minus 3x minus 20 equals 0. The first thing that we have to do, yes, we need to get the coefficients. In here, a is equal to 2, b is equal to negative 3, and our c is equal to 20. Next, you are going to use the ratio to get the sum. That's negative b over a. So our b is negative. Take note, we have a constant negative here. So we have negative and the value of b is negative 3 and the value of a is 2. And if we are going to simplify this expression, then our sum will be 3 over 2. And to get the product, x sub 1 times x sub 2, using the ratio c over a, our c is negative 20. So we have negative 20 there. And then our a is 2. So if we simplify this expression, then our sum is, or our product rather, is negative 10. Let us check again if our values here are correct. If we have 2x squared minus 3x minus 20 equals 0, the correct factors are x minus 4 and 2x plus 5. Zero product property, we are going to equate each factor by 0 and we are going to solve for x. For x sub 1, it will become 4 and for x sub 2, that will be negative 5 over 2. If we get the sum, 4 plus negative 5 over 2, it will become 8 minus 5 all over 2. So we have 3 over 2, just like what we have here. And for the product, 4 times negative 5 over 2, positive times negative is negative. 4 times 5 is 20, and then we have over 2. And negative 20 over 2 is negative 10. And we have a negative 10 here. Did you get it? Okay. Now, let us proceed in obtaining quadratic equation. To obtain the quadratic equation, given the sum and product of roots, you are going to use the concept. We have here x squared minus the sum of the roots. You need to affix the variable x and then plus product of roots equals 0. Again, we have x squared minus sum of roots with the variable x plus product of roots equals 0. Now, this is our first example earlier wherein the sum of roots is negative 7 and the product of roots is 12. The problem here will become the sum of the roots of quadratic equation is negative 7, just like what we have here, and then the product is 12, just like what we have 12 here. Now, you are asked to find the quadratic equation. This time around, this is what we are looking for. And again, the only thing that you have to remember is this concept. We have x squared minus the sum of roots with the variable x plus the product of roots equals 0. Then we will be having x squared. This is constant again. The negative is constant. So you have minus. The sum of the roots is negative 7. So we have negative 7. And we do not forget the variable x. And then the product of roots is 12. So if we simplify, it will become, we have two negatives here. It will become positive. So you will be having x squared plus 7x equals 12. And you will notice the equation that we derive here is the same as our equation here. So this one is definitely correct. Did you get it? Okay, let's have example number 2. This is our example earlier also, wherein the sum is 3 over 2 and then the product is negative 10. The problem here will be the sum is 3 over 2 and then the product is negative 10. We are going to look for the quadratic equation. We are just going to use the concept x squared minus the sum of roots with the variable x and then the product of roots equals 0. We are going to substitute now. The sum is 3 over 2 and then the product is negative 10. If we are going to simplify, it will become x squared minus 3 over 2x minus 10 equals 0. How are we going to simplify? We have a fraction here. Yes, we are going to multiply the whole expression by the LCD or the least common denominator. In this case, our LCD is 2. So we are going to multiply the whole expression by 2. If we do that, the resulting equation will be, how did we get that? We multiply 2 times x squared, that's 2x squared. If we multiply 2 to negative 3 over 2x, what will happen? Yes, we will be canceling out 2 here. So the remaining will be negative 3x. And then if we are going to multiply 2 and negative 10, that will give us negative 20. So the equation is 2x squared minus 3x minus 20, which is the same as our equation here. Okay, I hope you get it. Let's have the next example. What if we have like this? The roots of a quadratic equation are 5 and negative 5. We are going to find the quadratic equation. This time around, the given are the roots and not the sum of the product. So for us to be able to use this concept, we simply get the sum and product. Since the roots are 5 and negative 5, okay, then the sum will be equal to 0 because 5 plus negative 5 is equal to 0. And then the product, 5 times negative 5, that is negative 25. Then we are now ready to substitute the sum and product here. So it will become x squared. Our sum is 0. You have the variable x. And then our product is negative 25. 0 times x is 0. It is unnecessary for us to write this one. That is why we will be having x squared minus 25 equals 0. This is our quadratic equation. Another example here. The roots of a quadratic equation are 1/2 and negative 2 over 3. We are going to find the quadratic equation. Again, since the given are the roots, let us get the sum and the product for us to be able to use this concept. In getting the sum, we have 1/2 plus negative 2 over 3. You are going to get the LCD, which is 6. So we will be having 3 minus 4 all over 6, wherein the result is negative 1 over 6. And if we are going to get the product, multiply numerator to numerator, denominator to denominator. So we have negative 2 over 6, which can be simplified into negative 1 over 3. So we have here the sum, and then this is our product. We are going to substitute here and also in here. If we do that, the sum is negative 1 over 6 and the product is negative 1 over 3. To simplify further, it will become x squared plus, because you have two negatives here, so it will become plus, and then 1 over 6x minus 1 over 3. Again, we have fraction here. To simplify, we need to multiply the whole equation by the LCD. This time around, what is the LCD? Yes, the LCD is 6. If we do that, if we multiply 6 to each and every term here, what will happen? You have 6 times x squared, that's 6x squared. If we multiply 1 over 6 and x, we are going to cancel out 6, so the remaining expression will be x. And if we multiply 6 times 1, that is 6, divided by 3, that is 2. So the expression, or the quadratic equation, whose roots are 1 over 2 and negative 2 over 3 is 6x squared plus x minus 2. Now, sum and product of roots again, the only thing that you need to remember, to get the sum, that is the ratio of negative b over a. To get the product, that is the ratio of c over a. And in obtaining the quadratic equation, you just need to use the concept x squared minus the sum of the roots. You need to affix, we have the variable x here, and then plus the product of roots equals 0. That's it for competency number 4. I hope you get it. Thank you for watching.